Now let's discuss converting using our molar mass. To begin, let's take a look at converting grams into moles of a substance. Okay, so for example, let's say that I give you 180 grams of water, of H2O. I'm asking how many moles of water are present in this mass. Okay, so the first thing that you have to do is find that molar mass. So you look at hydrogen. In H2O, I have 2 hydrogens. So you take the mass, the average mass of hydrogen on the table, 1.01 times 2 gives 2.02. That's the contribution of mass of hydrogen. For oxygen, on the table you see it's got a mass of 16. So we'll go oxygen, 16. And there's only 1, so carry that over. Find the sum, and we have 18.02 grams per mole. Now that I have that value, in order to cancel out the right units, you need to set this up as a ratio or a fraction so that we can use it as a conversion factor. So we'll do that now. It's going to be 180 grams of water to start. We want to multiply it by the ratio, the conversion factor. And we want to make sure that we have the right unit on bottom. Since we start with grams on top, we need grams of water on the bottom and moles of water up on top. So according to the molar mass, there are 18.02 grams in 1 mole. So the last step is you can divide that starting mass by the molar mass. So 180 divided by 18.02. We're going to just, using mental math, you see 180 divided by 18. That's going to be approximately 10 moles. Okay. For the CST, they're going to require that that you do mental math. You're not going to have a calculator, so this is going to be the easiest way. Okay. So we'll take a look at going the opposite way now. So we want to convert grams, or convert moles into grams. So I'm going to say I start with 3 moles of carbon dioxide now. We're going to take a look at carbon. Carbon has an atomic mass of 12.01 times the 1. We only have 12.01 contributed from carbon. But oxygen, with its mass of 16, I have 2 of these in the substance, so multiply that by 2. We get 32.00, which is going to add up to 44.01 grams per mole. Now, just like we did before, since we have this molar mass in grams per mole, we can set it up as a ratio, as a fraction, used as a conversion factor. We're going to begin just as we did before. We're going to start by writing out the 3 moles of CO2. Then you multiply by your conversion factor. Since I have moles on top, though, this time, I need to have the moles of CO2 on bottom. That way, you can take the top and the bottom, they divide out, and they cancel the unit. So 1 mole of CO2 is 44.01 grams of CO2. Now this time around, we're going to multiply the starting moles by the molar mass. That cancels out the moles, and we'll end up with grams. So I'm going to do this again without a calculator. Since it's 0.01, I'm going to approximate that as just 44. 3 times 44. So that's going to give you 88, what is that, 132? 132 grams, approximately 132 grams of CO2. So if you're doing a lab, you're doing an experiment, you want to make sure that you're more precise, but on a standardized testing environment where you won't have a calculator, you have to do some rounding, do some mental math. Now I'll give you a second, go ahead and work these problems, and then we will work on them together. I'll assume you've done that now. To find the number of moles in a 10-gram sample, you must first find the molar mass. Okay, you want to go from moles, from grams, I should say, from grams to moles, so that's molar mass. To find the number of grams in a 3.50 mole sample, So again, we're connecting mass to moles, moles to mass. We need molar mass. Now to complete the table below, we're beginning with 10 moles of calcium. 10 moles of calcium. So I will go ahead and pull up a table here. If we're looking at calcium, 40.08 is the molar mass. So 10 moles of calcium with a molar mass of 40.08. So my factor is 40.08 grams per mole. Since I have moles, I'm starting with moles on top, I can write this as a fraction with moles on bottom. 40.08 grams of calcium divided by 1 mole of calcium. So we'll multiply 10 times 40.08 divided by 1. And again, we're going to do these rounded to the best of our ability. So 10 times 40 is going to give you approximately 400 grams of calcium. Okay, approximately. Now, 35 grams of NH3. So this time around, we're going to look again for our NH3. We have nitrogen 14.01 and hydrogen 1.01. So we'll find that molar mass first. Our nitrogen 14.01, hydrogen 1.01 times 3. So that's 14 plus 3, going to give you 17.04 as its molar mass. But this time I start with grams, so it's 17.04 grams on the bottom and the 1 mole of NH3 up on top. Now we're going to approximate this again. We're going to take 35 divided by 17. Okay, so 35 divided by 17 is approximately 2. It's a little bit more than 2. But if you think 17 times 2 is 34, 35 is pretty close to that. So it's a little bit more than 2, but that gives you a very good approximation. Now I have 0.00250 moles of C2H6. So we're going to take our carbon 12 times 2 is 24.02. Hydrogen 1.01 times 6 is 6.06. Combine those and you get 30.08. It's 30.08 grams per mole. Since moles are what we start with, you want that mole on bottom of C2H6, and our 30.08 grams of C2H6 on top. So you're going to take 0.00250 times 30. Now this one, it's a little bit harder to do in your head unless you consider that you can shift the decimal around. If I think about shifting the decimal over, we've got 25 here, 25 times 10 to the negative 4. So 25, if I were to take 30 and break it up into 4 pieces, right, 25%, you're going to have 15 as half, and break that again into 7.5. So just doing mental math, we can see it's going to be 7.5 grams as a quarter. So that 250, 7.5 grams. And with the decimal shifted, it was, let's see, that was a quarter, so it was 0.25. That's going to be 7.5 and 2 over. Let's see here. You know what? Just so I don't mess up mental math, I'm going to check it with a real calculator too. But no, these are definitely more challenging. I'm going to multiply that. I was on the right track. 0.075. Okay, so that's going to be, again, approximately 7.5 times 10 to the negative 2 power, or 0.075. Since you won't have a calculator, right, this would definitely be one of the challenge problems. So you got to be super comfortable with the math to get there, but hopefully you'll be able to kind of work your way to get there. Now, 450 grams of PCl3. So we're going to look at our PCl3 now. Phosphorus 30.97, and then Cl 35.45. So 30.97 for phosphorus, 35.45 for chlorine. Got to multiply that one by 3. So that's going to be, now we're just going to start getting our approximation out, right? 30 is about 31, 35.5, that'll be about 71 when it's times 2, 101, 106.5. Okay, so about 106. 31 and 106 is going to be, what, 137. So about 137 grams per mole. It's not exact, but about 137 grams per mole. So I've got 450 grams. I'm going to have to take that 137 grams on the bottom, 1 mole on top, and we'll take 450 divided by 137. Well, this is close to 150. So 450 divided by 150 is about 3. Okay, so since this number is slightly less than that, it's going to be a little bit more than 3, but it's right around 3. Here, our next one, we have 5 times 10 to the third grams of FePO4. So if you want to think about that in your head, 10 to the third is a shift to the right. It's 5,000, okay? 5,000 grams of FePO4. Fe, our iron, is 55.85, so we'll say Fe is about 56. The P in PO4 is 30.97, so again about 31 for the P. And the oxygen is 16. Do that times 4 gives 64. So we'll add these all up, and you get 56, 60, 120, 151, 151 grams per mole. We're starting with grams. So we're taking that 5,000 grams and we are going to divide the 151 grams to 1 mole. So if you take 5,000 divided by 150, the best way to do this mentally is think 150 and then 300 and then 450. That's 3 times. Just keep going up by your 150s, okay? 300, 450, you're going to have 600. From 600, you can keep going up. And notice, at this point, 300, 450, 600. So this is, that would be 4 moles to 600. Up to 5,000. We're going to keep working that up. Let's see, so 600, 750, 900, 1150. Yeah, that's going to take a while. So mental math will get you there. If you think of it from 450, that's about 3 times 10. It's going to be in the neighborhood of 30 over. I'll get an exact number for you. That exact number will be 5,000 and divide 151. It's going to be 33.11. Okay, so we can approximate it, which is what you're going to have to do on the CST. You approximated it to around 30. It is actually 33.1. So hopefully that was helpful. Now I'm going to